I am going to walk you through a typical mass spectroscopy question found in A-level chemistry, international baccalaureate, as well as advanced placement chemistry if you're in the US. The important parts of a mass spectroscopy graph are usually the very last peak, which tells us the actual mass of the molecule, that peak there, and then sort of individual fragments. So popular ones that I see over and over again would be a peak at say 15, which is usually CH3, or a peak at 29, which is CH2, CH3 and ethyl group. C double bond O, so the carbonyl group, is at 28, OH 17, and so on. So just once you know those sort of individual fragments, along with other information you're given in the question, you can piece together what the molecule is likely to be. So with that said, let's work this out. Compound B is a branched chain alcohol, which has the following percentage composition. Calculate the empirical formula and deduce the molecular formula of compound B. So the empirical formula is the simplest whole number ratio of each atom within a molecule. And its relationship to the molecular formula is that once you add up the RFM of the empirical formula, it will divide a whole number of times into the molecular formula, which will tell you then what the molecular formula is. So let's see what that looks like. And the first thing we need to do is work out the moles. The next thing to do is then to divide through by the smallest number. So SM, smallest number. And you can clearly see that is 0.98. Those numbers you can round to the nearest whole number. So that's going to be 6, that's going to be 14, and that's going to be 1. So the empirical formula is going to be C6H14O. Now the next thing I need to do is work out the RFM of the empirical formula. C6H14 is 102. And I just said previously, the relationship between the empirical formula and the molecular formula is this number will divide into the molecular formula, the RFM of the molecular formula, a whole number of times. If we look at the graph, and we'll zoom in, you can see the divisions on the scale looks to be, that number there is going to be 105, that would be 110, that would be 115, and that would be 120, which means that peak there that I've just gone over, that is going to be around about 101, 102. So therefore, the RFM of the molecular formula is also 102. So 102 divided by 102 is obviously just 1. So the conclusion is the empirical formula is the same as the molecular formula. Suggests why there is a small peak at MZ103. Before we answer this question, let's discuss what I just mentioned. So the fragment pattern is this region here. And the fragment pattern gives you an idea of what the molecule is going to be made up of. So you piece together the different fragments like jigsaw pieces, and it makes up the whole molecule. In this question, we're not given enough information, so that is why it's not asked you. However, it does talk about the MZ peak also being, so the MZ peak is this last peak, by the way, which is known as the molecular ion peak, which is the heaviest peak on the graph and tells us the RFM of the molecular formula. And we've just worked out the molecular formula to be, the RFM of the molecular formula to be 102, but they're telling us there's actually a tiny peak at 103. So what is the reason for this? The reason for this is because of the presence of isotopes. The common isotopes you see, the halogens, so like chlorine 35, chlorine 37, bromine 79 and 81, and also carbon, which is what this one is, so carbon 12 and carbon 13. So we can see the molecule is only made up of carbon, hydrogen and oxygen. So the fact that it's only just 1 unit bigger suggests the presence of carbon 13. Okay, that's it. Check out the other videos I've made on this topic. The links are in the description below, as well as spectroscopy as a whole, right? So NMR, mass spectroscopy, infrared, and chromatography. Thanks for watching.